Welcome, and today we'll be looking at the proof of differentiation. So let's start with the basics. A straight line can always be written in this form: y equals mx plus c. M is the gradient, c is the y-intercept. And if you choose 2 points and you try to find the gradient, which is the change in y over the change in x, you'll get that same answer, m, which is the gradient. And if you do that here, you'll get the same again. You'll get the same here again. So the gradient, the rate of change, it is constant. So now we've got a graph of y equals x squared. And now you can see that you can't really look at the rate of change with 1 or 2 points and just figure out the gradient, because the steepness is constantly changing. It's not constant. There's another way we can do this. We can draw a tangent to a point and then find out the gradient of that, but it takes too long. You'd have to draw a tangent for all the points, and that is just not efficient. So choose 2 points. Choose 2 points. Let's say this is N and this is L. Now if you draw a line which is tangent to these points, you'll get yourself the gradient by using change in y, change in x. And if you just, so N is at a point X, and if you move L a bit closer, then your line starts to become more accurate, so your gradient starts to become more accurate. So if you move it even closer, your line will start to get closer and closer. Gradient will start to become more accurate and accurate. So N is at the point X, at the coordinate X, and if N is at X, then L is just a little, then L is at X plus a tiny bit more X. Now the way you can write this is by using the lowercase delta, which is like this, X, and this just means X plus a tiny little bit more of X. So L is at the X coordinate with X plus delta X. Let's write this as a coordinate N is X, which is what we're just calling this point. We're not really making it a number. We're generalizing it, and if this is X, then the Y coordinate is X squared, because we're going to have y equals x squared. So then L is going to be X plus delta X and X plus delta X squared. So now that you've got the 2 coordinates, you're going to find the gradient. Okay, so the gradient is going to be the change in y over the change in x. X plus delta x squared minus x squared. All we're doing is we're subtracting our y values. Then we're going to do the same for our x values, and we're going to subtract x. Going to get x squared plus x delta x plus x delta x squared, and you're gonna have that all over delta x. Your x squareds I'm going to cancel that. Then everything else will cancel out to give you just delta y over delta x equals 2x plus delta x. Now imagine on the graph, right, closer you have L to N, then the more accurate the gradient becomes. If you have L on top of N, you can just say that delta x will just become 0. dy by dx, this is 0, so you're going to get 2x plus 0, you're going to get 2x. Thank you for watching, and I'll see you in another video.